Hey everyone. So today I'm going to go over the quiz review. This is Unit 1, Test 2 review. And we're starting off with problem number 1. So it says quadrilateral ABCD is shown in the graph in the XY coordinate plane. Quadrilateral ABCD will be translated according to the rule. Now, first of all, let's remember that a translation is one of our rigid motions. This means our shape will be the same shape and size, right? Now, translation, we could also remember, is a slide. So a slide, right? Now, our rule is xy becomes x plus 3, y plus minus 4 to form a prime, b prime, c prime, d prime, right? Now, we need to break down this rule also. The x plus 3 tells me that we're going 3 to the right. And y minus 4 means that we're going 4 down, right? So we're sliding 3 right, 4 down. Now, it wants us to select the correct orientation of our shape from one of these blue shapes over here, and then plot it on the plane, right? Now, we can't necessarily click and drag it because we're not on the computer, but we can select it by circling. Now, when we slide something, the orientation doesn't change, so we should be selecting the shape that looks like it's facing the same direction. Now, when we do this on our plane, what we could do is just count. We already converted our rules into words that we know. 3 right. So we're going to start with A, go 1, 2, 3 right. And then we're going to go 4 down. 1, 2, 3, 4 down. You can see my little red dot is floating everywhere here. Right? Let me just double check that. 1, 2, 3, 4 down. Yeah, perfect. And that is going to be A prime, right? Our next one is B. So go 1, 2, 3 to the right. 1, 2, 3, 4 down. We could do B prime, right? Now at this point, I want you guys to check and try to complete this yourself if you haven't done so already, right? So pause the video, try to get the other 2 points by yourself. Now, if you have paused and you're coming back, then cool, let's do this. If you are still going, let's check that work. So C, 1, 2, 3 to the right, 1, 2, 3, 4 down. That is C prime. And D, 1, 2, 3 to the right, 1, 2, 3, 4 down. That is D prime. We can connect this. Now, I'm sorry about the lines. I haven't used this tablet on my computer in a long time. So we connect those lines and we should see that this shape is the same shape. It's just shift it 3 to the right, 4 down. If we wanted to, we could also write all of our coordinates just for the practice, right? A is at -6, 3. Your x coordinates first. It's your original coordinates. B is at -4, 5. C is at -1, 6. And D is at -3, 2. So if we wanted to, another way to do this, if we wrote our coordinates, if we want to find our new coordinates on the grid, remember, we could always apply that original rule. Look back up at part A, that original rule, you might see my little red cursor bouncing around there, the x plus 3, y minus 4. If I add 3 to all of these and subtract 4 from the y, then this will give us our rule also. What does that mean? So if we look at A prime, if we want to find our x coordinate, we could do -6 plus 3, which will give me a -3. And then our y coordinate will be 3 minus 4, which is a -1. And this also lets you double check your work. If I go to -3, -1, notice that's where my a coordinate, a prime coordinate already is. So this shows me that I did my work properly, right? And we could do this for the rest of them. So B, that's a D. Let's make that a B. B prime, whoops. -4 plus 3 will give me a -1. 5 minus 4 will give me 1. C prime is -1 plus 3 is 2. 6 minus 4 is 2. And last but not least, D prime, that's going to be -3 plus 3. They cancel out. They leave me with 0. And 2 minus 4 is -2, right? So we could double check all our coordinates, but they all match up, right? And that will allow us to check our work. let's go to part B here, right? So our second problem, part B. It says quadrilateral ABCD maps onto A double prime, B double prime, C double prime, D double prime. Now, why are these called double prime? It's because this is a different transformation than the one we did before. We're still using the same shape. I know I don't have it on my screen, and I'll explain for why that isn't necessarily needed in a moment, right? But it says it will undergo a different transformation that will map A to A prime, B to B prime, C to C prime, D to D prime. Now I've already messed up. This should be A double prime, B double prime, C double prime, D double prime. I apologize about that, right? The transformation will consist of a reflection over the y-axis followed by a translation. Now, notice here, it doesn't tell us what that translation is. Once again, we should all be looking at this text up here. It just says a translation. It doesn't tell us what that translation is. Now, it says point D double prime is shown. So they give us point D double prime, right? And then plot it in the plane after the transformation. They want us to plot A double prime. And we're also going to write the coordinates for it, right? So one way to think about this is let's first think about D. So let's recopy the coordinates for D. It says D is at -3, 2, right? And we know that something happens. We do the reflection, and it gives us new coordinates that aren't on there. And then we do our translation, and then that gives us D double prime, which is going to be at what? 6, 2. 6, 2. So we need to find these middle coordinates somewhere, right, in order to figure out what the translation was, right? So if I plot D, which is at -3, 2, right here, that red point, that is our D point. Now, our first thing that happened, what did we do first? If you look back up at our text, it says a reflection over the y-axis. Which way is my y-axis? I'm going to change colors down here to, let's make it gold. Our y-axis is right here. Ooh, man, I apologize. Not perfectly straight line, but we get what it is, right? That's my y-axis, up top, y, right? That's my y-axis. Now, what happens? We need to reflect. Remember how we reflect to our y-axis? We count to the line of reflection. So I'm at D, and we go 1, 2, 3 to the line, and we want to do the same exact distance away. 1, 2, 3 away from our line of reflection. And this point doesn't have a name, right? This isn't D prime. This is just a floating point that we did after our first transformation, right? So this was our reflection. But then it says we translated it. Remember, right here, or up at that text, it says a translation. So how do we get our floating point to D double prime? Well, it moved right 1, 2, 3 spaces. So right 3 spaces. Now, what does that mean? So if I write my floating point coordinates here, it's at 3, 2. And you might notice that's only one thing changes here, and that's my x coordinate, right? It goes from negative to positive, and then it goes from 3 to 6. So what's that change there? It's that +3 of my x coordinate. So our rule, our translation rule is x plus 3, and our y stays the same. So this is what happens, right? So this is our rule that happens right there, right? And our first transformation, once again, was a reflection. So does this answer my question? No, this is just how to understand how to get the answer to the question. Now, what is the answer to the question? And once again, this seems like a lot of work because I'm explaining every single part to make sure we understand. Now in purple, let's find A, right? If we have point A, I'm going to rewrite point A down here. They want to know where's A double prime. A is at -6, 3. And I'm also going to plot it on my grid. We go to -6 on my x. That's left 6, up 3, and I plot point A. Now, for point A, our first little floating point, we need to reflect over my y-axis. So we go 1, 2, 3, 4, 5, 6 to the line. 1, 2, 3, 4, 5, 6 away on the other side. And that's going to give me my floating point. So my floating point is at 6, 3. So now that we have that floating point, What's that second step we have to do? Remember, it's this translation rule that we found here. We need to move it 3 to the right. So in order to find a double prime, what do? We add 3 to my x coordinate. I apologize. So we get 9 because 6 plus 3 equals 9. And then my y coordinate stays the same. So that should still be at 3. We could also do that on our grid by going back to my purple point there and moving it 1, 2, 3 to the right. And that is a double prime. And we could check our work. Just look at the coordinates of that a double prime. It's at 9 on the x and 3 on the y. And isn't that what we got right down here? Yes, it is. We could box that off. It looks nice and pretty. And we are done with problem number 2. So let's head on over to problem 3. So now problem 3, it looks like we have a lot going on here, but it's really not that bad. Let's take a look at what it's asking. It says quadrilateral A, B, C, D, and E, F, G, H are shown in the coordinate plane. Part A, quadrilateral E, F, G, H is the image of A, B, C, D after a transformation or a sequence of transformations, which could be the transformation or a sequence of transformations. Which one of these work, right? It says select all that apply. So let's go step by step. Let's look at all of them. Now, the way that I do this is, first of all, we need to figure out what letters match up here. And if we look at our original name up top, you could see that A is the first letter, the E is the first letter. That means those points are what we call corresponding. They have to match up. And then we have B and F, C and G, and then D and H. So those are the corresponding points. So for instance, if I start at C and I want to run these transformations, like let's look at our first one. A says a translation 3 units to the right, followed by a reflection across my x-axis. Now, if you follow along, I'm going to do things on the screen and then erase them. You do not have to do this on your paper. You could follow along. You can write on your paper. That is up to you. But what does this mean? I want to see if I could use this translation to get C, if you look at the name up top, in the same spot as G because they're corresponding. So let's move C 3 to the right. 1, 2, 3. This is going to be my floaty point right now. My floaty point is purple on the grid. That's after the first translation 3 to the right. Now we want to reflect across my X. Remember, your X is down here. This is your X. This is the line of transformation. So we do that by going 1, 2, 3, 4, 5, 6 to the line. 1, 2, 3, 4, 5, 6 away. And if you notice, is G at that new point? No, G is not at that new point. There's actually nothing at that new point. So this cannot be a translation that works, or a transformation that works, or a sequence of transformations that work. It is nothing, right? So let's try our next one. A rotation of 180 degrees about the origin. Well, lucky for us, we have a rule for this. We could take our X and Y coordinate, and we actually just change the signs of both the coordinates. So for instance, if I wanted to try C again, right, because we know that C needs to match up with G. What are the coordinates of C? I'm going to write it right on the grid. The coordinates are 1, 6, right? So if we make both of these negative, because they're both positive, so if I go down to -1 on the X and -6 on the Y, what's there? -1, -6, that is point G. It matches up. Okay. But what if just one of these matches up? Does that mean it works? No, let's test another point. Let's try A, right? A is right here, and A is the first letter in the name of the shape. E is the first letter in the name of the shape, which means they have to be corresponding. So let's try A. A is at what? -4, 4. We try -4, 4, right? So my X coordinate now needs to be positive when we rotate it, and then my Y coordinates can be negative. So now we're going to +4, -4, and it matches up with E. Oh, E matches up. That's awesome. This means two things match up, right? So that is at 4, -4. Let's try one more. D. What does D need to match up? It's the last letter in the name. H is the last letter in the name. If D matches up, we have -2, 2. So it's going to be +2, -2. So +2, -2, H is there, right? That's at +2, -2. So it works. All of them match up. Well, all three. I'm not testing the last one to save us some time, but if you test it, guess what's going to happen? It's going to match up. So this is one of our answers, but it says select all that apply, right? So we need to do that. We need to test other things. Let me just erase my grid, clean it all up for us, and let's try our next one, right? So I'm going back to C. Going back to C. Now it says translate a translation 12 units down, followed by the reflection of the y-axis. So let's actually, I'm going to change colors here just to make it a little different for us. Go green. Boom. All right. So we need to go down 12 units. So notice my little green blurb. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is my floating point because we only did one transformation. And now we need to reflect across our y-axis. Our y-axis, I'm going to highlight in that goldish yellow again. Our y-axis going up and down. That's not perfect, but it's that bold line right down the middle. Right? So if I reflect across that, we go 1 to the line, 1 away, and notice that gives us G. So one of our points is good. Let's try another one, right? Because we got to make sure it works. Let's try B this time. We haven't done B yet. So I'm going to count B down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That's 12 down, right? Followed by a reflection across the y-axis. We go 1, 2, 3 to the y-axis. 1, 2, 3 to the other side. Is there a point there? Uh-oh. There's no point there. So once we have one with no point, what does that tell us? That tells us that this cannot be a transformation. It cannot be a transformation. Try our next one. So our next one, let's change our color to, let's go back to a darker red, right? It says a reflection across our y-axis, followed by a reflection across the x-axis. We reflect over our y and then reflect over our x. So if I'm at C, I need to reflect to my y. That's 1 to the left, 1 away. There's my floating point. Then we go down 1, 2, 3, 4, 5, 6. I touch my x-axis. 1, 2, 3, 4, 5, 6 away, and that brings me to G. They're the ones who are supposed to match up, so we're good there. But once again, we can't just trust one time. So let's try another, right? Let me try D. We go 1, 2 towards the y-axis, 1, 2 away. There's our floating point. And then we go 1, 2 to the x-axis, 1, 2 away. Up, there's our floating point, or our new point, H. Are D and H supposed to match up? Yes, they are. They're the last letters in the name. Let's test A. Or let's test B because B didn't work last time. So let's just double check B, right? So first, we need to reflect over our y-axis. We go 1, 2, 3 towards. 1, 2, 3 away. We get our point. And we go 1, 2, 3, 4, 5, 6, 7 towards my X. 1, 2, 3, 4, 5, 6, 7. And it lands on F. R, B and F matching. Yes, B and F are the same spots in the name. They match. That gives us 3 points. I'm going to say that it works. Boom. It works. Right? And my last one, a reflection across the line, Y equals X. Now, I'm going to save us some time here. I'm going to show you on the graph what that line Y equals X looks like. It's going to be this line that cuts through our plane. Ooh, at the intersection points like this. It cuts through the plane. It's not, my line's not perfect. If we use a ruler, it'll make it better. But one way you could think about this, remember how we did this in class. You count to the line, turn and count away. So C, if we count to the line, we go, sorry about that, 1, 2, 3, 4, 5 to the line. Make a right turn. So now I'm going down. 1, 2, 3, 4, 5. That's where my point should be. That's what point, if you look at the name, G should be. Is G there? It's not. That tells us that this is not our answer. This is not our answer. So we have two answers here, B and D. This is our problem. Let's move on to the next one. This one is a quicker problem. I know last one was really, there's a lot of work going on there. We had a lot of work going on at that problem. So let's look at this next one. So on this problem, it's saying triangle ABC is graphed in the XY coordinate plane as shown. Triangle ABC is reflected across my x-axis to form triangle A prime, B prime, C prime. What are the coordinates of C prime after the reflection? And what axis do we want? The x-axis. Oops, sorry about that. That's a little crooked. X-axis, right? So first of all, let's highlight that x-axis. Is that our vertical or our horizontal? I hope you guessed or knew it was my horizontal. I'm so sorry about my horrible writing. Right? So there we go. And if we reflect over it, just like we did in the last problem, we want to reflect C. So how many chunks to the line is it? How many spaces to the line? We go 1, 2, 3, 4. So what do I have to do? Same distance away. 1, 2, 3, 4. And there's my point C prime. What is that at? It is at 6 on my X and 4 or negative 4 on the Y. So C prime is at 6, negative 4. So what do we select in our multiple choice? There it is. It is D. Oh, wrong. There we go. D is our answer. Is at 6, negative 4. Told you that one was nice and quick. Moving on to the part B of this problem. So part B of this problem, it says, now we're doing something a little different. It says triangle XY, ABC, sorry, on the XY coordinate plane is now rotate it, right? Now here's our rotation, 90 degrees, what direction? Counterclockwise, about point A, to form triangle A prime, B prime, C prime, or A prime, B prime, C prime, all double primes. Which graph represents this? Well, there's one thing that we need to know. What are we rotating around? We're rotating around point A. And when we know that, if I draw it up on my top grid, point A is at 3, 2. When you rotate around a point, that point should not move. So we need to find the graphs, first of all, where A is at 3, 2. So if we go to our first graph, we go to 3, 2, there it is. That's A. If we go to our second graph, 3, 2, A's not there. What does that tell us? This cannot be our answer. Our third graph, we go to 3, 2, A's there. This could be an answer. And then our last graph, right? We go to 3, 2, A's not there. Once again, not our answer. Already, if you know that part, if you know that A should not move places, you have a 50-50 chance of answering this. Now, here's my next question. Well, what way does it say? It says counterclockwise, right? Counterclockwise, if you look up top, is us rotating that direction, the opposite of what a clock should, right? So that means if you look at our graph, our shape should rotate this way 90 degrees, 90 degrees, right? So now we could guess, oh, well, what shape does that? What shape is moving that 90 degrees? And that is going to be, our answer is C. C is the one that rotated 90 degrees. I'm going to give us one more way to double check this, right? So just in case we're not sure. If you need to skip ahead, you can, but I'm giving you another way to show you how to do this. This is what we did in class. First, we found our vectors, A, C. And the vector of AC is how many to the right? 1, 2, 3 to the right, and 2 up. So our vector is 3, 2. Whoops, wrong bracket. 3, 2. So once we do that, if we want to find A, C prime, we need to apply our rule to our vector, right? So we apply our rotation rule. Our 90 degrees rotation rule, XY, becomes opposite sign Y, comma, X, right? So if we do that to this, we bring our Y up front. That's going to be negative 2. And we change its sign, and then we leave 3 in the back. So how do I find C prime? Well, we could check it on the graph that we chose, and we do that rule. The negative 2 tells me move 2 left, 1, 2, and then 3 up, 1, 2, 3. And there's our C double prime. We could check this on the graph that we didn't select. 2 left, 1, 2, 1, 2, 3 up. That isn't our point, right? So we know that that is not our answer. Our answer is going to be C. Next up, we have our problem. We have a triangle on here, and they want to know what is changing on this triangle when we rotate our triangle 180 degrees. So we're looking down at the bottom here. It says rotate 180 clockwise. Now, whenever we rotate 180 clockwise, counterclockwise, it does not matter. It will bring us to the same spot. What does matter, it's around the point 3, 4. Let's mark that point off. We go 1, 2, 3 on the X, 1, 2, 3, 4 on the Y. Oh, that's point C. If we think back to the last problem, we know that the rotation point should not move. So this point shouldn't move. And it creates a new triangle, right? It wants to know what characteristics of A prime, B prime, C prime will be the same as ABC. So first of all, when I rotate this, will the coordinates of A prime change from A? Well, is A our point of rotation? It is not. So those will not stay the same. They have to change. Same thing goes with B. Is that our point of rotation? It is not. So the coordinates have to change. So we're Xing that one out too. Now, the perimeter of triangle A prime, B prime, C prime. How can we figure this one out? Well, if we think about it, when we rotate something, and you can put your hand on your desk, you could put your hand on your computer, you could put your hand somewhere, and if you spin your hand, does the outside line of your hand change size? Does your hand change size at all? No, it will not change size. So we could check that one off. Same thing goes with the area. If you have your hand, rotate it. Does your hand get bigger or smaller? It does not. So that will not change the area. And our next one, the measure of angle B. Well, when we think about measures of angles and shapes, this gives us our shape, its shape, right? So if we change the way B looks, our shape will change how it looks. And when I rotate the shape, the look of the shape of the shape does not change. So this has to be the same. And our last one, line segment A prime, B prime, the length. Once again, the size does not change of the shape, so this length should stay the same. Next problem. Now, this problem is the one that's a little more confusing. It says that we have triangle JKL will undergo a transformation to create J prime, K prime, L prime in the XY coordinate plane. What transformation will make sure that JKL is congruent to J prime, K prime, L prime? Now, if we think back to everything we did in this lesson or over the last couple weeks, we learned about what we call rigid motions. Now, rigid motions are important because they make sure that our pre-image and our image are congruent or the same shape and size. They do not change the shape's size or the way it looks. It might change its orientation, the way it's facing, but that's about it. So if any of our rules fall in line with one of the things we learned about, then we're good to go. So if we look at our first one, it says negative X, negative Y. This is our rule for our rotation of 180 degrees. Now, do rotations change shape and size? They do not. So we could check that off. Our triangles will be congruent. Our next one, we have negative X. Our Y stays the same. This one is a rule for reflecting over the Y axis. When you reflect over your Y axis, your X coordinates change signs. Now, once again, reflecting, does that change our shape and size? No, it doesn't. That means our triangles will be congruent. We could check that one off. On to the next one. Now we have Y minus 5. Y minus 5, this looks like our very first problem that we did, kind of. Y minus 5 means that we are translating and if it's our Y, subtracting, that means down 5. We translate down 5. Now, if I translate down 5, will that change my shape and size? It will not. So we stay congruent. But oh, look, Next one looks exactly the same, except now we have our x plus 3. Well, this is still a translation, right? But now we're translating our x plus 3, which is 3 to the right, and then down 5. Well, if we slide in two directions, does that change the shape and size of our triangle? No, it keeps it the same, so they're still congruent. Wait a second. Our next one looks a little different. We have 2x and 3y. Now, this is where things change, right? We are multiplying our x and y by numbers other than 1. Yeah, but Mr. Up top, we had a negative. Well, that's still a negative 1, right? If you multiply something by a 1, whether positive or negative, the core value of that does not change. What do I mean? 6 times 1 is 6. 6 times negative 1 is still, there's still a 6 there. It's a negative 6, but it's still a 6, right? So that doesn't change the shape and size. It might just change where it is. When we have something that multiplies by 2 and 3, this changes the size. So this will not give us congruent triangles. Now, if we look at our next one, what's happening? We have the negative, and then we have a plus 3. This is two rules combined. First one, it looks familiar. This is like B. We are reflecting over what? The y-axis. And then our y plus 3 is kind of like D, if we had the x plus 3, except instead of going right, it's on my y. So we are translating. Whoops. And what direction does y tell us? A positive y tells me up 3. Now, if I reflect and then translate, does that change the shape and size of my triangle? It does not, which means that our figures will be congruent because same shape and size. That's what congruent means. So here, all of these are our answer except for E. All of them except for E. Awesome work. Moving on to the next one. So next up, we have a parallelogram on our plane, right? So we have a parallelogram on our plane, and it says quadrilateral PQRS is transformed by translating it 6 units to the right and then rotating 90 degrees clockwise about the origin. This part is important, right? 9 degrees clockwise. But we also need to translate 6 units to the right. We're translating 6 units right and then rotating 9 degrees clockwise about our origin. Which coordinate pairs represent vertices of P prime, Q prime, R prime, S prime? What we're going to do is we're going to do both these transformations. So first, let's translate 6 units to the right. So that means if we just take every single one of our points, I'm starting at P, and move it 1, 2, 3, 4, 5, 6 to the right, that gives me our floaty point P. What about Q? 1, 2, 3, 4, 5, 6. That gives me my floaty point, Q. Come on down to S. 1, 2, 3, 4, 5, 6. That gives me our floaty point of S. And then R is 1, 2, 3, 4, 5, 6. That gives me my floaty point of R. And as you could tell, if we connected these, they would all give us that same shape, that same quadrilateral. Now, what I'm going to do actually is show us another way to do this, and that's by looking at the coordinates. Let's write the coordinates of P is at -3, 7. Our new P, after we translate, our floaty point P is at 3, 7. Now, this -3 and 3 is just a coincidence. Not all of them are going to be like that. So let's look at Q. Q is at 4, 12. Floaty point Q is at 10, 12. Now you might notice that our y's stay the same here, but that's because we didn't add or subtract anything from our y. Next up, we got R. Oops, sorry. S and then R. I did it in that order, so I'm keeping it in that order. S is at -3, -7. Now, if S is at -3, -7, our floaty point of S is at 3, -7. And last but not least, R is at 4, -2. So our floaty point of R is at Sorry, I lost track. 10, -2. Right? So these are all our floaty points. We still have to do something to these points. And that's going to give us our prime notation. Let me change colors for this next part. Our next part says we're going to rotate, right? And that's going to give me P prime, Q prime. Oh, I almost wrote R again. S prime, R prime. Right? So we need to apply our rotation rule. And our rotation is 90 degrees clockwise around the origin. Clockwise is important because these are not the rules that most of us learn. We learn counterclockwise. Remember, 90 degrees clockwise, 90 degrees clockwise, CW, is equal to 270 degrees counterclockwise, CCW. Right? That's an important part. So we have to use that rule. So that means XY turns into Y negative X. So we apply that rule to all of our points. What does that mean? That means I'm picking up my 3, moving it to the back, and changing its sign. So now up front for P prime is 7, -3. Take my 10, pick it up, move it to the back. That gives me 12, -10. Once again, like we did earlier, pause the video here. I want you to try S prime and R prime yourselves, and then you could self-check. Okay, welcome back. If you didn't do it, that's your loss. Oh, sorry, I lost my little track there. So take 3, move it to the back. Does that mean I make my 7 positive? No, you leave it the same. -7, we change the sign for 3 to -3. And last but not least, we get -2. Take the 10 to the back, -10, right? I am not going to plot these points. We don't necessarily need to, right? What we are going to do is see if any of these match what we are given in our list, right? 7, -3. We have -12, -7. Oh, 7, +3. That's not it. And none of them match. 12, -10. We go down the list. -12. Nope. Going to get a positive. Oh, 12, -10. E is one of our points. -7, -3. Nope. 12. Oh, -7, -3. There's one of our points. Our last one, -2, -10. We go on our list. We don't even have a -2 in our x coordinate. And those are all of the answers for this problem. All that are answers that showed up were just for Q prime and S prime, right? Moving to our next question. All we have to do is find the center of rotation for the point that is given. So to do this, what do we do here, right? Now, if we remember, when we rotate around something, and you could try this with your arm, right? If you spin your arm or rotate your arm around your shoulder, keep your arm stretched out, and you spin it in a circle around your shoulder. Does your fingertips ever get farther or closer to your shoulder? No, your arm stays the same length, which means that our distance from our center of rotation to our points that we rotate need to be the same. Now, what does that mean? If we look at E, and we think E to A prime, and then E to A, are those two purple lines that I drew the same distance? No, they are not. So this cannot be one of our answers. This is not our center of rotation. Now, if I go to green and I go to F, we could test this out with A again, right? So F to A prime. Whoops, I'm sorry, that is not a line. That is some wiggly jiggly thing. F to A prime and F to A. Although these aren't straight, we could tell. Are they the same distance? Hell no, they're not the same distance away. So that cannot be my answer. This leaves me with one option, D. But let's see what I'm looking at here, right? If we draw D to A, boom, and D to A prime, can I perfectly confirm that this is the same distance? No, I don't have a ruler on my screen right now. If we did, we could confirm this, right? But what do we notice with all the rest of them also, right? D to B, D to B prime. They look like they're the same distance. Those other ones are obvious that it's not, right? So this has to be our center of rotation. This is going to be our center of rotation. D is our answer. So we could write point D. Next problem. And I think this might be our last. So our last problem, it says point B prime is the image when point B is reflected. So first we're doing a reflection over the line x equals 3. And then, another one. So we're reflecting it again over y equals -1. The location of B prime, that's important, is at 1, -5. What is the location of point B? So let's graph B prime. B prime is at 1, negative, I almost went up. We go down, 1, -5. And this is my B prime. They want to know where is B. So we actually have to work in reverse. We're not going from B to B prime. We're going from B prime to B. Got to work in reverse. So the first thing we have to do is actually the second thing it tells us to do. And that is my reflection. I need to find my little pen thing. Oh, it's up there. Right? It's this little reflection here over y equals -1. Where does y equal -1? So if you go to your grid, how can we figure this out? Well, if I go down 1, I see y equals -1. Would it make sense for me to draw a line straight up and down? No, that would just be my y-axis. I got to draw this horizontal line, as you could see me drawing it across. This is my horizontal line. That is our first reflection we have to do. So let's go back to our point. I'm going to change my color back to red there. Oh, I am sorry, people. I am off with this. We're almost at the end of the video. Now I'm falling apart. So we got to reflect. How do we reflect again? Count to the line. 1, 2, 3, 4 to the line. Do the same distance away. 1, 2, 3, 4. That brings me right here. This is my floating point. Now that's only one reflection. We have to do another reflection. So let's go and figure out what our next reflection's over. I'm going to make this one green. Our next reflection is over x equals 3. We do a similar process. Where do we see that x is equal to 3? I go right 3. We have that point right there. X equals 3. Would it make sense for me to draw a horizontal line again? No, because that's just my x-axis. So we go vertical. We go vertical. There we go. Now, if we do this reflection, this will give us our point. How do we get there? We go 1, 2 to the line, 1, 2 away from the line. And that brings me back to point B. That's our original pre-image point. What are the coordinates of B? Coordinates of B are at 5, 3. Those are the coordinates of B. That is our answer. And just like that, boom, we are done. Thank you for watching the video. If you need to, go back. If you really need to, email me. See y'all next time.